A very good morning to all of you. I cordially welcome you all for this engineering thermodynamics course. So the today's classroom discussion topic is numerical problems on the diesel cycle. That is to find out the air standard efficiency and mean effective pressure of the diesel cycle. So the motivation for the today's class is it is important to predict the performance of a diesel cycle, because whenever any diesel engine is working, so definitely we should know at what efficiency it is working. So the outcome of the today's lecture is you should be able to solve some numerical problems on the diesel cycle. Because in the previous class, we discussed about the diesel cycle working principle, and similarly how can we plot the diesel cycle on PV diagram as well as on the TS diagram. And similarly, we derived the air standard efficiency formula of the diesel cycle. Now, based on the previous class inputs, now in the today's class, we are going to solve some important problems on the diesel cycle. So it is one of the previous gate examination question. So the stroke and cylinder diameter of a CI engine, because the compression ignition engine is nothing but the diesel engine. SI engine is nothing but petrol engine. So compression ignition engine is nothing but is a diesel, are 250 mm and 150 mm respectively. So here he has given the stroke and diameter is nothing but the bore. So first you write down the given data. So the length of the stroke is equivalent to 250 mm, convert into SI units, that is the 0.25 meters. And the diameter of the cylinder he has given as 150 mm, that is the 0.15 meters. So clearance value he has given 0.0004 meter cube. And we know that how can we calculate the swept value when we know the diameter and length of the stroke, that is the area into length, that is the Vs is equivalent to pi by 4 d square L. So with this you calculate swept value is equivalent to 0.004418 meter cube. And how can we estimate the total cylindrical value? It is nothing but the swept value plus clearance value. So it is the total value. So he is asking us to calculate the air standard efficiency. So here, if you want to calculate the air standard efficiency, this is the basic formula. So it is a 1 minus 1 by r to the power of gamma minus 1 into rho to the power of gamma minus 1 by gamma into rho minus 1, where rho is equivalent to cutoff ratio and gamma is equivalent to adiabatic index and r is equivalent to the compression ratio. So here R value is not given. So we know that R formula is V1 by V2. So V1 is nothing but it is the swept value plus clearance value, that is the total value. So already we calculated here, it is the swept value plus clearance value. So it is this particular one will give you the compression ratio as 12.04. And coming to this particular cutoff ratio, so in the previous class, we defined that cutoff ratio is equivalent to V3 by V2. That is at which point the fuel will be cut off. And similarly, the fuel ignition, that is the fuel supply will start and fuel supply will end. So that is basically giving us information about the cutoff ratio. So we find out the cutoff ratio as 1.55. Always the cutoff ratio will be greater than 1. So rho is equivalent to 1.55 and the compression ratio is equivalent to 12. So just to substitute in this particular formula, we are able to find out the diesel cycle efficiency is equivalent to 59.3%. So just to go to the another problem, a diesel engine has a compression ratio of the 15, that is R value given as 15, and heat addition at constant pressure takes place at 6% of the stroke. So this is the heat addition at 2 to 3 process. He is saying that this particular the heat addition, it takes place at the 6% of the stroke. Stroke is nothing but here is a V1 minus V2. It is the stroke value. It is the stroke value. So he's saying that is the 6% of the V1 minus V2. So find the air standard efficiency of the engine. So it is the basic diesel cycle. So whenever a problem comes on the diesel cycle, so first you plot either PV diagram or the TS diagram of the diesel cycle. So here the input data, you know, that is the R is equivalent to V1 by V2, that is 15 value already given. So this is the formula to find out the diesel cycle efficiency. So rho cutoff ratio, that is nothing but the V3 by V2, but directly the cutoff ratio value not given, but is given that the statement the heat addition at constant pressure takes place at 6% of the stroke. So heat addition is this particular 2 to 3 process. So V3 minus V2 is equivalent to 6%. that is a 6 by 100 or the 0.06 into Vs. Vs is nothing but is the V1 minus V2. So whenever we are substituting this, we are able to find out the rho value is equivalent to 1.84. So substitute in this equation of the air standard efficiency. So we are finding out the diesel cycle efficiency is equivalent to 61.2%. So the next question on the diesel cycle is the mean effective pressure of a diesel cycle is the 7.5 bar. That is the MEP. That is the mean effective pressure. And the compression ratio is 12.5. So R is equivalent to 12.5. And initial pressure value is also given as a 1 bar. And now is asking about find the percentage cutoff of the cycle. Find the percentage cutoff of the cycle. So that is percentage cutoff is equivalent to is a rho minus 1 by is a R minus 1 into 100. And we know the mean effective pressure formula. So that's why the mean effective pressure value is given. So from which you find out what is the cutoff ratio. And after finding out the cutoff ratio, already has given the compression ratio. So substitute in this particular formula rho minus 1 by R minus 1 into 100. So now we are in a position to find out the percentage cutoff of the cycle is equivalent to is a 10.78%. So like this, we are able to solve some problems based upon the diesel cycle. So in the today's class is dedicated to solve some numerical problems on the diesel cycle. I hope you understood the concepts of the diesel cycle air standard efficiency and mean effective pressure. So thank you one and all for listening this lecture on the numerical problems on the diesel cycle. Thank you.